Alright, so it's like day 13, I believe, of the 30-day scripting challenge, and this video is coming out a bit late. I am sorry. Had some stuff in person going on, like school. School's kind of fun, I don't know why people at school, I don't want to go to school. I actually enjoy going to school, it's nice. But anyways, so day 13, it's a gun system. We're gonna get into ray casting, hit detection, projectiles. Those are actually a little more complicated, so we're getting into some nice stuff, but it's not really too complicated. The only complicated part is the ray casting, but that's like 5 lines of code maybe? It's probably not, but get the general idea. So a couple things before I start the video. I made a folder in storage called assets where I have a particle effect of our bullet, which I'll be using, and then I've also added a gun model into our starter pack that has a decal called Crosshair, which will be the player's cursor when the gun is equipped. And I also have 3 animations ready, which will be for the gun. So when the player equips it, it'll play an equip animation, and then it'll have an idle animation, and then a shooting animation. So yeah, that's it for the setup. You can make your own animations or use the ones that I have, which you'll see in a little bit. But other than that, let's get into the coding part here. So for a gun system, there's not a lot of things we want going on. It's pretty straightforward. We just want to shoot our projectile towards where the player clicks their mouse. So we'll raycast from the player's mouse in 2D space into 3D space, which Roblox has its own function for that, which is really neat. And then we want to move the bullet. We want to clone this bullet tracer right here and have it move along the raycast. So we will lerp it, which is short for linear interpolate, or we might tween it. I don't know for sure. Pretty simple. It's not as hard as it looks, and we'll do it on the client, so that way we'll save up some usage for the server, and it's also really easy to do. And then after that, we'll use server-side detection to tell when the bullet has hit the end. We don't want the client to handle that, because then we could just it would be not trustworthy on the client. And then as well as that, we'll have that animation be constant, so it'll make more sense when we get to the coding part. So we're first going to make a local script. So I like to put my local scripts inside starter GUI. That's just me, but I know people put it in starter player scripts. I think there is a difference when you put it in starter GUI or starter player scripts. I think there is, but I don't know for sure. I probably should look more into that, but I like to put my local scripts inside starter GUI. So this will just be called the gun client, and then we'll get into the scripting part. So we first have to access the gun, when the player equips the gun, and activates the gun. So first, we're just going to get our local player. That's not a, I don't have a clue for that. So local player is just going to equal to game.players.local player, and then we're also going to grab the mouse here. So local mouse is going to player : get mouse. Oh, the things around there. And then also we want to get the gun. So we'll just say local gun is equal to player.backpack : wait for child gun. And then as well as that, we're going to now connect our functions, right? So we want equipped, unequipped, and activated. So we'll just say gun.equipped : connect function, and then gun.unequipped : connect function. And actually, I didn't know this. Equipped passes in the mouse. I didn't know that actually. So you don't even need to use a variable here, because mouse is already passed and equipped. I actually didn't know that, surprisingly. And then we'll have a gun.activated : connect function. So first things first here, when we equip the gun, we want to play our animation. So we'll just get our animation. So local equip animation, local unequip animation, and then local shoot animation. So in this case, I have my own animations, so I'll go put those in real quickly. Alright, and also I forgot, it's the idle animation, not the unequip animation. The unequip animation is just the equip animation, but in reverse. These are just free animations I found in the toolbox, which they're animations. So I mean, yeah, I'm not a good animator, so I wouldn't make anything good. And then also we can get our custom crosshair. So local crosshair is going to equal to gun : actually we don't need to do : because it's gun dot. I put the decal inside of the gun, so the gun.crosshair, which is the thing. So gun.crosshair.texture. which is going to be the asset ID. So when we now equip the gun, we're gonna first like play the animation and have the crosshair change. So we'll just say mouse dot icon. In this case, let's actually get the original crosshair icon so we can revert it actually. So we'll say local default mouse is going to equal to mouse dot icon. So now we'll say mouse dot icon is just going to equal to our crosshair, which is the texture. And then when we unequip it, we'll say mouse dot icon equal to default mouse. And here we're going to load up the animations. So we'll grab the humanoid right here. So we'll just say local humanoid is equal to player dot character find first child of class, and then the humanoid, and then we'll say humanoid dot animator. Actually, we'll probably just get the animator right here because we don't need to use the player's humanoid. So local animator find first child of class animator, because the animator is inside of the humanoid. So from here we're just going to say animator load animation equip animation play, and then we'll do a speed of 1, or actually, and this will just be 1, or actually we don't even need to put a 1 here, we can just replace it like that. And that's it, all we need to do for our equipped animation here. So if you give it a quick test here with the gun, the crosshair changes, but the animation isn't playing. Okay, I'm a little bit stupid. it needs an animation object. You can't load a string onto it, you have to put an animation object. I'm sorry, I'm actually a little stupid for that. You need the animation object. And also this we can just change to wait for child. We don't need it to be find first child of class because we're waiting for the player to load, it doesn't matter. So this has to be instance.new. Whoops. Whoa. Instance.new animation, and then equip animation dot animation ID, and that will equal this right here. And I'll do that for the rest of them real quickly. Okay, yeah, so that was the issue. So now, there we go. So I can now equip the gun, and then it has its own, what's it called? Like, in the animation, it would, detach the mag. Oh, no, it would put the mag in the gun, but in this case, this gun doesn't have that. It's just a simple gun model. So yeah, crosshair changes, and the animation plays. So now, we can get into the unequipping animation, and to do that, we'll just do this in reverse. So all we would do is we would do this, right? And then we wouldn't change the fade time or the wait, just speed. It would be -1, which would play the animation in reverse. So if I equip the gun and then I unequip the gun, it'll play the animation in reverse. So then we can simply just say, actually I'll have to make a variable for this. So local track, and then we'll just say track dot ended or stopped. I don't remember. Hold on. You gotta track dot ended wait. Though if I'm correct, I don't entirely know. Yeah, never mind. So when you call unequipped, the gun, the tool model, will already have been destroyed. So putting weight here won't do anything. So I guess if you would want to. If you would want to make the unequip animation, you'd have to get a custom listener, but I'm not gonna do that. So just ignore that. That was my fault. I should not have done that. So now that the gun's equipped, so let's also get the idle animation. So we'll make this so local equip animation track is going to equal to this, and then we'll say equip dot ended wait, in which case here, once the thing is finished, we'll say, actually we don't even need to get now. Well, I'll load the idle element. So animator load animation, and then our idle and then we'll play it. And actually we'll add a variable in the idle animation. So local playing idle. So that case is gonna be false, and then we'll make it so that playing idle equal to true, and then we'll just check here if playing idle, then I'll actually move this variable here, and then we'll have the local running idle. So we'll just say running idle right here, and then we'll put the animation track thing right there. So running idle colon stop, and that's it. It'll stop the idle animation. So now if I were to equip the gun, it'll wait for it to be equipped. Actually, made a tiny little mistake here. Running idle is not this. This is running idle. It's gonna equal to this one. This one is just going to be equal to the. I don't even think I actually need to put a wait statement here because it was giving an error right here. So that shouldn't actually need to go there. All right. So there we go. That's the idle animation. And now when I unequip it, it's not. So you equip it and then the idle plays. When you unequip it, the idle stops. Does not want to stop. It's saying attempt to index nil with stop. Alright, yeah, there we go. So now it'll equip it, and then it's gonna play the idle animation right here, and then I unequip it, and then the gun will go away. In this case, you can make an idle animation if you like want to. Not an unequipping like feature, but I'm not gonna do that in this video. So there you go. Right, that is the like animation part all good to go for the client here. Now we're also going to now make the shooting information. So this logic here is for the visuals. Now we're gonna wait for when the gun is activated. This is where our raycasting logic will go. So first, like when we're raycasting, we have to get the origin, which is where the ray is gonna start, right? So in this case, we want it to originate from this part here called fire. That's like the barrel. That's where we want the stuff to come out from. So we'll say local origin. Local origin is going to equal to the gun dot fire. That's our origin thing, and then dot position, not the part. That's our origin, right? It's a vector 3. And then we're then going to get the we're gonna get something called the mouse's unit ray, which is like our 2D mouse, right? And then we're gonna use a function called screen point to ray, and that's how we can raycast from the player's cursor to a 3D space, right? So we're just going to say local mouse unit ray, which is going to equal to the current camera, and then we're going to do this function called screen point to ray here. In this case, it'll create a unit ray from the position on the screen to, I think I said that wrong, but we need to use this function. It's important. And then we'll put in the mouse.x and then the mouse.y, and then we're not going to use a value. And this is pretty much like, to say this, it's kind of gonna get like the 3D direction from the camera, like using the mouse, if that kind of made sense. And then now we're gonna get the direction, which is what direction our like raycast is gonna go in. So we're just gonna throw local direction, and that's going to equal to the mouse unit ray. And then we'll do maybe something like times. I usually either do 500 or 1000 for most rays. This is 1000 studs, by the way. So well, actually, it's gonna be even farther, but this is how far we want the like kind of bullet to travel in, or well, how far we want the ray to go to register shots. And then from here we'll make our raycast. So we can have the raycast parameters be defined outside of the activated function. So we could do that like here. So we'll say like local raycast params is going to equal to raycast params dot new, and then params dot raycast. Maybe I should just change it to ray params instead of raycast params. So ray params dot filter type equal to enum dot filter dot raycast filter type. That's different, I think. Wait, I don't know. I have like pretty bad memory. Filter descendants exclude, and then we also have to say ray params dot filter descendants instances, and then we want the player dot character. So this will block out like it'll not include the player's character when we raycast, so the player can't shoot themselves. And then it'll set the filtering type to exclude, so it won't include anything in this table, if that made sense. I'll put a link for the raycasting in the description for anyone who's confused. And then we'll run the raycast here. So we'll say local ray is going to equal to workspace colon raycast, and then our mouse unit ray dot origin, which is one of the values of our unit ray, and then the direction and our raycast parameters. And that's it for the raycasting. So now we'll do the rest of the logic, which will be like where it'll hit, right? So we'll simply say local hit position is going to, we want like a variable for the, like where the ray hits, so set that to nil. And then we're going to check if ray, then, like, so if you have a ray, like in this case, if the ray exists from here, if this returns a result. In fact, I probably could just call this variable ray result here, so that way it's easier to understand. If there's a result from this raycast, right, we're going to set the hit position to equal to the ray results, and then in this case there's a couple values passed, like unit and normal, and then I think magnitude or something like that, I don't remember. Dot position, right, which is just a position of where the result is, like where the raycast hits. If there isn't a result, meaning the player like shot into nothingness, we're going to, instead of making like the shot like not appear, we're just gonna have the gunshot like shoot into the distance, right, into the air. So we'll say hit position will equal to mouse unit ray dot origin plus the direction. So it's just gonna shoot off into nothingness, pretty much. Now, around this point, we want to like send the server that we've send the server the information, so that way they can run the like damaging check, right? But I also want to add in some visuals here. So if you're watching the previous like episodes, like where I talk about the framework here, we create the remote events like through the initializing setup, right? When all of the modules are initialized, and we can actually do that for the gun client here. We can create the remote event at the start, or actually no, we're not. We're just gonna make it in our replicated storage. So this is what the client will fire to send over to the server. So this will be called like, I don't know, like fire shot remote, right? So we'll grab that right here, say local fire remote is going to equal to game.replicatestorage.fireshot. And actually I probably should get replicated storage at the top, because we need to grab the bullet, so it'll just be replicated storage.fireshot right here. And then we'll say local bullet template is going to equal to replicated storage.assets.bullet tracer for later on when we want to like make a visual. So for the visual, there's something important I gotta talk about here. So we don't want to create a tween that has a certain amount of time. We want to tween the bullet, or we want to move the bullet at a constant speed. So to like visualize this, let's say I shot a bullet from this part to this part right here, from here to here, right? If I were to make a tween, so the goal would be moving apart from here to here, and I set the goal to be 2 seconds long, it would take 2 seconds to move that part from here to here. So the amount of studs it would move per second would be shorter than if I were to shoot the bullet from here to here and have that time be 2 seconds. It would take the same amount of time from the bullet to travel from here to here, then from here to here. We want it to be constant, so the bullet would travel faster if it were to be shot from here to here instead of from here to here, if that made sense. So to do that, we're going to give it a constant speed, and we're also gonna get some more like raycasting logic that we'll use for our like part. So we're first going to grab the unit, which is like the direction we want to fire in. So local fire direction, it's just going to equal to the, if I could type parentheses, the hit position minus the origin, and then dot unit. And then I'll leave in the description like raycasting information about why we use like things like dot unit, dot origin, dot position. This will give us the like direction we want to fire in, right? And then as well as that, we can get the distance, so it'll be used for calculating our travel time. So to do that, we'll use a function called magnitude, which just gets the distance. So local distance is going to equal to, once again, the hit position minus the origin, and then we'll do dot magnitude, if I could type. And then now to get our like speed, we're gonna use a cool little thing where we just divide the distance by like how fast we want the bullet to go. In this case, I would say like we'll have the bullet travel at 300 studs per second. So we'll make a variable appear by our gun called local bullet speed, and we'll have it equal to 300. In this case, it'll be studs per second, I think. Or yeah, I think it'll be studs per second or not. And you could have this be faster or slower depending on each gun you're using. This one is just going to be for one gun though, but you could have this be modular for tons of guns. So we're going to now get the time, how long it'll take. So local travel time it'll equal to our distance divided by the bullet speed. And that's that for the logic here. Now to like visually like make the like bullet like move, we're going to like first clone our thing. So we'll say local bullet is just going to do the bullet template, and then we're going to clone it, and then we're also going to anchor it. So I think it is anchored already. Is it anchored? It's not anchored. So we'll just anchor that here. And then we'll set can collide to false, which is pretty important. Now here we're going to set the bullet dot position to our origin, which is the gun dot fire dot position, the barrel, right? And then the parent to workspace. So bullet dot parent will equal to workspace. So we'll do a couple like things related to time here, so that way our bullet will move at a constant speed. We're gonna want to get the time that the bullet has started. So to do that, we'll just simply use a function called os.clock. So local start time, and we're going to use a function called os.clock, which will give us like the current like time. I don't exactly remember what it's called. I think it's called like the Unicode time or something like that. My memory is like really like not with me right now, but I'll try to leave a link in the description for os.clock. It's way better because there's a deprecated function. Actually, it's not deprecated, but there's a function called tick here, but it's not as good as os.clock. I'd recommend using os.clock instead of tick. And then we're gonna get the end position. So local end position, it'll just be the origin, and then in parentheses here, we're gonna add the fire direction and then times it by the distance. So it'll just tell us where our end position is. In this case, like also like the end of the array. But this will be for our bullet. And now that we have this, we can connect it to a run service loop where we'll just have it like run every frame, or yeah, every frame on player, where we're simply just going to move it slowly along the array, or like along that like line we created until it's reached the end. Then we're gonna destroy it. In which case, by the time it reaches the end, the time it will have taken will be equal to the travel time here. So let's grab run service here. Actually, whoa, I didn't mean to do that. Let's grab run service right here, and I'll show you what we can do. It's actually really cool. So we can do run service dot render steps connect function, and then from here we're gonna grab the elapsed time. So local elapsed time, it's just going to equal to the os.clock minus our start time. And then here we're just going to check the if elapsed is greater than our travel time, then we're going to destroy the bullet. So bullet : destroy. And then if it's not, we're the bullets dot position, it'll equal to the origin, and then we're just going to origin plus, and then the direction that we're firing in, and then multiplying it by the time elapsed, and then the bullet speed. So it will it'll move along that imaginary line we've created based on how high our bullet speed is, so faster or slower. And then also we can, to prevent memory leaks, we'll just say local connection, and then we'll say connection will equal this. And then when we destroy the bullet, we'll say connection : disconnect. This will prevent memory leaking, so that way when our bullet is destroyed, this run service loop will stop. And that should be it for our bullets here. So let's go and test it out here to make sure everything works properly. We'll grab our gun, and now if I shoot, and now we have an error. Okay, I forgot to put the dot direction on our mouse unit array. So it was multiplying the ray times the number. Alright, now we go. So here we've got our gun right here, and now if I shoot, there we go. As you can see, it fires the projectile. Every time I shoot, it'll fire the projectile. Now I can, there's no, there's no cooldown, so I can spam this thing as much as I want. I can put an auto clicker on, and it will, looks like the part where it's firing isn't exactly on the barrel, but that's easily fixable. So I could put an auto clicker on, and this thing could fire as long as it needed to, as long as it would need to. So to that, we'll simply just add a cooldown, or I'm pretty sure we can just put task.wait 1 here, and that should oh no, that won't work. Okay, we'll have to put a cooldown on here. So we'll make another value here, just say local cd, and then that'll equal to 1, and then what we're going to do is, actually it'll equal 0 right now. And then we're going to say is if cd is equal to 0, then we'll run all of this. Whoops, we'll put that right here. and then we'll put a task.spawn. So we'll say cd will equal to 1, which is just going to be like how fast our fire rate is. So this can like be its own value, like set in the gun, and then we'll run a task.spawn here, so that way it'll like decrement the value. So it'll just say, actually we don't even need to do that inside this function. We can do it outside of it. We'll just simply say task.spawn function. Actually, we'll put this up here above the activated, and then we're just going to constantly decrease the value by. On second thought, actually, I don't think I'll use the task.spawn method, because like I'm thinking there's multiple ways to make a cooldown thing, but there's a better way we can do this. We can turn cd into a boolean, and then we can have another variable called cd time. In this case, it'll be how much time I want in between each shot, and then we can change this so we can say if not cd then, and then we'll set this to equal to true. So we can use a function called task.delay at the end of our script here, and if you read the description there, it's gonna wait. It's gonna pause the function to run until a given duration has been finished here. So we can just say task.delay cd time and then give it this function, where then we'll say the cd will equal to false, so after the cooldown's done. Now this can build up over time. Like a lot of task.delays can use a lot of memory, but this is just a simple way that you can run cooldowns. Though I usually would create a module script that would handle all the game's cooldowns for anything. Like you could just call it cooldown module or whatever, cooldown service or something. It'd be a utility. So this will handle cooldowns. So then now I won't be able to spam. So as you can see, I'm spamming my mouse a lot, but it'll only fire every 1 second here. And we'll also go play the attack animation. So we'll do it right. We'll do it at the start, I guess. We'll just say animator : load animation, and then what was it called? Shoot animation : play. And then it'll now play the shooting animation. As you can see, it's playing the shooting animation. We probably should have the idle animation paused here. So we'll say running idle : stop, and then once this is done, so we'll just say local track, and then we'll do that right here. We'll say track : play, and then track dot ended : connect function. In this case, we're just going to set the running idle : play, and that should fix that little jittering part there. So let's go give that a try here. In this case, it's just resetting itself back to the thing. So we'll just say adjust speed, and then we'll put it to 0, so the way it'll freeze, and then we'll say adjust speed, and then put it to 1 here. And for some reason it's saying we'll give a task.wait here when the gun is equipped, so that way we can let the idle animation load, because the idle animation will only load after the animation has been completed. So there we go. Now it'll fire the gun like normally. And if we wanted to, we can make a value that'll say firing, available to fire. So we could say local ready, that'll equal to false, and then so in this case we're gonna set ready to equal to true once the equip animation has been finished here. So ready will equal to true, and then when the thing is unequipped, we'll just set ready to equal to false. So now when I equip it, I won't be able to shoot until the equip animation has been finished. Alright, and now we can go to the server, so just go inside the shared folder here, and then we can make a new module, and it's be called gun service. Wait, no, it should go in services, not modules. What am I doing? So we're just going to grab the remote event here, so get storage, and then we'll say local fire shot event is going to equal to replicate storage dot fire shot, and then in our start here we'll say actually we have to get a run service thing going here. So actually I think I added run context. That's right. In this case, we want this to run on the server, not on the client. This is an attribute I added to the module scripts that we only want the server to run. So, or actually, as a matter of fact, you could just put the modules that you only want the server to run inside server script service. But, I should have. I'm not smart. I probably am, but I'm probably not at the same time. Anyways, I'm like feeling a fire shot event dot on server event colon connect function, and then we'll pass in the player argument here. So what we want to do is we don't want to trust the we don't want to trust the client with the raycasting logic. So what we want to do is we want to pass in all of the raycasting information to the server, and the server will do the raycast for us. So send in the origin, the direction, the travel time, and then the distance, and we'll pass this we'll call this right about here, I think, because that's when we have all of our variables. So fire was it fire? I named it differently for some reason. Fire remote colon fire server, and then send in our origin, direction, the travel time, and then the distance, and we'll run the raycasting on our server here. So I can just go on it, and I can copy this information here. Oh, this isn't a good idea to create the raycast params every single time. I'll rename this to player. I wouldn't create raycast params every single time, so I'll put the raycast params out here, and then I'll put this right here too, because creating raycast params is very resource intensive, and I wouldn't recommend doing that a ton of times. So with that, and then you can run raycasts in parallel, which I'll talk more about later on, with parallel Lua. It saves a lot of resources. We'll do the same exact thing. We'll say local array results equal to workspace colon raycast, and then our origin, direction, so the direction times the distance here to add a little more security. Calculate that, and then our raycast params. No, ray params right there. And then we'll wait the travel time, and then we're just gonna check the if ray results and ray results dot instance, which in this case is the object that it hit. Then we're just gonna check if the parent. So we'll check if the parent's a player. So local hit part will equal to the results dot instance, and then we'll get the character. So local character is going to equal to the hit part when find first ancestor of class, in this case model. So we want to find the ancestor because the hit part is a base part. So if I were to shoot this model of a door here, the hit wouldn't be the model, it'd be either the actual part in the model. So we want to find the ancestor. In this case, it'll be the model here, right? And then we're going to check if it has a humanoid. So if character and character colon find first child of class humanoid. So if the character exists and has a humanoid, then we're just going to say character dot humanoid colon take damage, and then we'll say 5. So that way if it has a humanoid, it'll take 5 damage. And that's it. We're done. That's the gun. And I don't even need an init function here, but I have it there first. It's built into, right? So now I'll issue the R6 here, and as you can see, I am hitting this NPC here with the gunshots, and yeah, he's taking a lot of damage, and I also killed that NPC over there. So yeah, I'm firing with the 1 second fire speed, by the way, which I'm probably gonna lower. And that's our gun system right there. It's got our attack animation, our equip, and an idle animation, and then a shooting animation as well. And that's it. That's the foundation for a third-person gun system. It's not first-person because I won't get into a first-person right now. For week 2, I don't think first-person guns are interesting enough. Actually, they are interesting, but I think it's gonna be a little too complicated for week 2, which is supposed to be pretty easy stuff. But yeah, that's it. Gun system. It's all about visuals on the client, and then the server has literally just the damage verification and raycast verification, while the client just handles all of the visuals, the particle effects and the animations. And that's it for the gun system. And I'm just gonna lower. I'll put this 0.3 or something, yeah, because I don't like this. Leave it in 1 second. Let's take a time. Whoops, right there. So now I can kill. I missed actually. That's crazy. Yeah, I can kill the R6. Now, right now, this is a semi-automatic gun. Right here, this gun is semi-automatic, which means you have to keep clicking. You have to keep clicking every time you want to fire the gun, right? Which some guns are not semi-automatic, some guns are automatic. So if you wanted to make it automatic, which Oh, actually, I have plenty of time. I'll show you how to make it automatic, actually. It's really easy. We're gonna switch it to user input service, by the way. I was gonna go on a, like, talk about how you could make it automatic, but then I looked at my clock and I have so much time on my hands. So let's grab user input service here, and we're gonna make another boolean here called firing, which will let you know if the gun's firing or not. So with user input service, we're just going to pretty much delete this activated. We're not going to use it. We're going to use input began. So we take all of this right here, and then the task that we would just like leave there, I guess. And we change it to something else. So we use a user input service here because it's easier because we can use mouse button 1 and while it's being held down. So this one on mobile support, but that's something I'm not gonna talk about right now. So user input service dot. Wait, am I like? Is there like a? What the heck is happening? User input. Why was it doing that? Input began the connect function, and then this is just gonna call every time the player does an input. So the input object, and then GP is the game processed event, which don't worry about that. It's just for GUI, like when you click on the GUI. So you usually do like if GP then return end. So the gun doesn't like shoot. So it was just like if not GP then. So if the player isn't clicking on a UI interface, right? So if input dot user input type is equal to enum dot user input type dot mouse button 1, then we'll just say firing the boolean will equal to true, and then while firing do. So while it is equal to true, we're just going to bring all of the logic right here. And then we can take out this task.delay, and also we could take out the CD thing here. Because it's not semi-automatic anymore. But if you did want it to be semi-automatic, you would create two separate functions here. So we'll take out the if not CD thing here. And we'll take out this task.delay, and we're simply just going to say task.wait, and then our cooldown. What was it called again? Did I call it cooldown? The CD time. Okay, our CD time here. We'll just wait that, and then this gun activated. Okay, now get rid of. And that's how you'll make it like. And then also we have to get input ended. So user input service dot input ended connect function. Same thing. Input game processed event. And then we'll say if input dot user input type is equal to enum dot user input type dot button 1, then we're just going to say firing, not fire mode, firing will equal to false. So when they stop the input ended, we'll set firing equal to false, and while they're holding down button, all of this will fire. So we'll put this to be right here actually. And then also I think this we could actually, who cares? I'll put the animation logic here. So this is literally just gonna run while the player is holding down the mouse button. It's really easy to interpret. Game process, by the way, as I said before, it's like for user interface elements. So there you go. That's how you'll make it auto. Oh, I didn't put a task.wait. Shoot. Every time you do a loop, you gotta put a task.wait. So where is that? Line 65. The task.wait should go outside right here. There we go. So now it'll work. So why does this thing keep opening? So now if I open up the gun, first like this will work, and now if I hold down M1, it will fire full auto. And it's super easy to make. Just use user input service. And now I can go bully this NPC over here. So let's make the fire rate like even faster, So back to our gun client here. Let's set CD time to 0.01. Or 5 actually. So this thing's gonna fire like a freaking minigun. Look at that minigun. And then we can obliterate this NPC here. Look at his health go down. If I can hit my shots, there we go. Look at that. Bam. Look at that. Gone. And look, see, this is the NPC right here. He's not safe either. Actually, I think he is safe. Alright, well yeah. That's that fully automatic gun. I don't think I'll put this in a paste bin, or actually no, I'll put in an RBXM file actually. So anyone can use this if they need to. That's it for this day 13 fully automatic. And then if you wanted to make it semi-automatic, you would just like have two separate functions for that. Pretty easy to do. And then one other important thing I want to talk about is something called object pooling. It's used a lot for projectiles. Instead of duplicating the template multiple times, you would only duplicate it once and then reuse it over and over again. Object pooling is really helpful. It saves resources. I don't think I'll talk about it in this video. I want to go to sleep. So yeah, that's it. I hope you guys enjoyed. What was it, day 13? And we're almost done with week 2. Only one more day left. Alright, yeah, thank you all so much for watching, and I'll see you for day 14.